Welcome back. Let's see. What are we doing today? We're going to go over the model again. We're going to update it, but first, let's go back over the two homeworks from the last 2 Mondays. All right. So what's the homework tonight? Redo number 5 on your graphing calculator, the quadratic regression with the new data. I'm going to give you new data today. Now, last time we did this, we were this far. Let's see. We did up to 28 days of data. No, I'm sorry. First, it was this. All right, this was 2 Mondays ago. All right, we were modeling the population. Now, that homework that time was how would you flatten the curve? How would you bring the top of, see where the red dot is, the top of that curve, where the red dot is? How would you bring that down? Okay. And a lot of you came up with some good ideas. Clearly, if alpha is less, look what alpha is, 0.03. Now, remember what alpha is. Let's see. Alpha is a constant of proportionality for DSTT, the rate of change of the susceptible population, which is negative IS times alpha. Alpha is a constant of proportionality. It's like the probability of getting infected, scaling the product of I times S, the size of the population of susceptibles, times the size of the population of infecteds. That's a typical differential model for predator-prey. Type things, right? So, or predator-prey, or commensalism, or symbiosis, that kind of stuff. So, if you bring alpha down, what we call the infection rate, I guess, we should flatten the curve a little bit, right? So, what if we bring alpha down a little bit? Where do we set alpha? Okay, on line 17. Let's make this a little bit bigger. Okay, so line 17, how about we make it 0.02 instead of 0.03? Let's see what happens. Now, the red dot is still going to stay where the max was, right? I'm not changing that, but the curve is going to flatten out, I think. Let's see. See how it's lower? So it's lower and it's spreading out a little bit. So it's taking longer for the infected population to get, to a max and then dissipate. But the max is now only 0.4 or 40% of the population, a little bit over 0.4. Before it was almost 0.6. All right. So now what does that mean? Well, how do you bring down the infection rate? You isolate, you separate like we're doing. You don't shake hands. You use masks, you use gloves, all that kind of stuff. You don't go out. But more preferable to that would be, it would be nice if we had a vaccine, right? Yeah, that would be nice. We don't have that yet. Okay. And then what else can we do? Well, some people did that and or this. What if we change the beta, the rate at which the infected people become recovered? Now, unfortunately, recovered is a misnomer. It should really be, DRDT really should be the rate of change of the removed population. It increases as a constant proportionality beta times I. The recovery rate, I guess you would call beta. And but it's not recovery because it's people being removed from the infected population. That could be death too, right? But let's not go there. All right. So what if we make beta bigger? So the rate of change of the recovered population is faster. All right. So let's do that. Where do we do that? Beta is on line. Where were we? Where do we set up alpha and beta? We were on line. What the heck? I just had it. I just reset. Okay, there it is. On line 17, we reset beta. It was 0.03. I made it less. I can make it even less than that. What if I made beta 0.01 instead of 0.005? So I'm going to double beta. So the rate at which people recover is going to be greater. And let's see what that does to the curve. Now let's look at the curve. It maxes out in around whatever the time units are here. I guess days. I don't know. These units, I don't know what they are. But it looks like 380 days. It maxes out to a little bit over 40%. All right. Let's see what happens if we run this with that bigger beta. Run it. So you decrease alpha or you increase beta or both. I'm doing both. And look at what happens. Now it takes over 400 days to get to a max for the infected population. That wave at the bottom, that curve at the bottom, that Governor Cuomo was always calling the wave. And look, the maximum infected part of the population is less than 20%. It's like 15, it's less than 15%. So that's good. Now, how do you change beta? Well, beta is the rate at which people get better, right? So that would have to be there's more ventilators if you're sick. Maybe there's some kind of, maybe that anti-malarial drug works. We could try using that with, they're also talking about using that with a Z-Pack. Or we should, preferably, we should get some decent antiviral medicine specific to this virus, but we don't have that yet either. But there you go. All right, so that was the homework from 2 weeks ago, 2 Mondays ago. Here's the homework from last Monday. All right, so here we were actually modeling the infected population of, where am I? The infected population, I think, are here, of New York City. Here it is. All right, now look at line 3. The list of data goes for your X components go from 1 to 28. So it's March 1st to March 28th. So it's 4 weeks of data, right? And it goes from 1 infected on the first day to 30,765 infected on the 28th day. Okay, so what I want to do with this is go over that homework. Now that homework was redoing number 4. See number 4 here? On the graphing calculator, whether you're using an emulator of some sort like Wabbit or that Chrome version of the emulator, that's fine. And see if we can basically redo this on the calculator. So tonight's homework is to redo this on the calculator. Okay, so you would send me a picture of your graph from your TID4 or Inspire if you're using the emulator for the Inspire, and your R squared. It doesn't give you an R value, but it gives you an R squared. So instead of correlation coefficient, it gives you the coefficient of determination. They call that R squared. But again, R is a percent, a number less than or equal to 1. When you square it, unless it's 1, it gets smaller. So R squared is even smaller than R. So if R squared is large, that's good. If it's close to 100%, that's good. It's really hard for R squared to become 100%. So let's see what your R squared is for this on the calculator. I didn't get an R squared for this on Sage. All right, so what I'm going to do is now I'm going to add data. Okay, so what I did was, all right, well, actually, you know what? Let's do last Monday's homework, okay? So last Monday's homework was to enter this data in the calculator and get a linear regression, see what the R is, right? Okay, let's do that. Hang on, let me get my data. Hang on, I got my data in here somewhere. This was Monday the 30th, I think. All right, so let me just bring up my data over here. Come on, where are you? There it is. Okay. All right, so let's see here. There you go. All right, so let me start. I'll go over here. Let me start the TID4 emulator. There it is. Good. All right, let's do stat edit. Okay, so I'm just going to do what we did from last week. That was 28 days, right? Then after that, I'm going to extend my Sage model for up till yesterday. Now, what's interesting is I found a database that doesn't only give me one data point per day, which was usually at 5 o'clock from New York City's NYC.gov, but also AM and PM starting on the 23rd. So we're going to have for, 31 days in March and 5 more days in April through yesterday, April 5th. We're talking about 36 days. We're going to have 50 data points because from the 23rd on, we get 2 data points every day, AM and PM. I had only these values we have right now are only for PM. All right, so let's do it. 1, enter. 2, enter. 3, enter. 4, 5, enter. 6, enter. 7, enter. Maybe I should do 1 week at a time. Let's do it. All right, so day 1 was 1 infected. Day 2 was 1 infected. Day 3 was 2 infected. Day 4 was 2 infected. Day 5 was 4 infected. Day 6 was 7 infected. And day 7 was 12 infected. Whoops, 12. Come on, 12. Okay, let's do 1 week at a time. What the heck? Okay, so second stat plot. Make sure one of these plots is on. How about this one? And that where it says type, that thing that's highlighted is a scatter plot. That's what I want. Okay, how about if I do I have anything in Y equals? No. Zoom 9. That sets up a window automatically for you, X min, X max, Y min, Y max to fit the data we just plotted. Okay, let's do a linear regression on this. Now, what the homework was last time was all 28 days. Give me a linear regression on that, similar to what we had in SAGE just a moment ago. And give me the R, the correlation coefficient, okay? Which was, what was it? I think on SAGE for 28 days, I got, where was it? I'm looking at my other computer, hang on. I have the output from this SAGE cell on the other computer, so I can talk to you about it. Okay, and the correlation coefficient was about 81.6%. Okay, 81.648%. All right, let's see if we get the same thing here, but that's for 28 days, right? So how about stat, calc, linear is number 4 or number 8, same thing really. L1, right? L2, right? And then I'm going to store this in Y1. So vars, Y vars, function 1, and then calculate. All right, so what we got. All right, I don't have my R squared here because I restarted this calculator from scratch. So what I have to do is second 0 is catalog. Go to, see the key that has the green capital D on it? Click that, skip down to the D's, and I have to get diagnostics on. This is what you can do tonight, except it's stat calc 5, not stat calc 4, not linear regression, but quadratic regression. Diagnostic on, enter, enter. All right, let's do the stat calc 4 again. Good. And don't worry about that. And Y1. Just so I don't have to type it in myself and I can graph it, see what it looks like. All right, so now we get an R of 0.89, 89.334%, let's say. But that's only for 1 week of data. Remember, I had 28 weeks of data and I had 81.648. Let's see what it looks like. And it's not great. It only gets close to like 3 points out of the 7. That's not great. All right, stat, edit. Let's add another week on. Okay, so 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Wait. Oh, I'm only doing 1 more week, right? So let's delete that. Let's delete, how do you delete that? I wanted to stop here. What am I doing? Can I just hit delete there? Okay, let's just do that much. Okay, let's go 7 more days of data because we got that, right? All right, so on the 8th day, the first day of the second week in March, I think that was a Sunday, by the way. Let's do it. Here we go. On the 8th day, there were 14 reported cases. Now, another problem with this modeling, of course, is that the data lags, right? They didn't have a lot of testing going on. If all of a sudden we get a ton of testing going on, it's going to mess up the data and it's going to like screw up our logistic model. But, well, let's see what happens. On the 9th day, were 25 reported cases. On the 10th day, there were 32. Dang it. On the 11th day, there were 53. On the 12th day, there was 88 reported cases in New York City by 5 p.m. Some of these were reported 4:30, some were 5:30, 5 p.m. On the 13th, it was 137 people. On the 14th day, I guess it was a second Saturday in March 14th, 2020, 185 reported cases. All right, then let's do stat, calc 4, enter, vars, y vars, function 1. I'm going to write over y1 because I don't really need it, what it was there already. And now the correlation coefficient is 83.397%. Notice when you square it, R squared, the coefficient of determination is a lot smaller, 69.550%. That's not great. All right, and then there's my Y. I just copied everything in there. I copied the A, which is 11.461-ish, 462-ish, and B, which is negative 45.747, which is wrong, right? Because you're not going to have negative 45 people infected on day 0. But that's what I copied there, just so you know. Trying not to round off. All right, so what does that look like? Ugh, not good at all. Wow, that's terrible. All right, stat edit. Let's add another week. All right, so I'm going to keep today's homework to being 4 weeks worth of data, but I'm going to update the model to up to April 5th with 50 data points, not more than 20, not just 28. So the homework tonight, you can just use what I'm doing here, but do a StatCalc 5 quadratic regression. Show me a picture of that and tell me what your R squared is, like 69.6% or whatever it is. Okay, so on the third week, starting on Sunday, March 15th, 2020, we had, well, let's do the 15th, the 16th, the 17th, the 18th, the 19th, the 20th, and the 21st. So that's another week, right? Oh, I did it again. This emulator is sort of slow. It doesn't keep up with the keyboard. Okay, on the 15th day, the third Sunday in March 1st was a Sunday, March 8th was a Sunday, March 15th was a Sunday. All right, we have 269 cases reported. All right, then on the 16th, 464. Then on the 17th, 923. Then on the 18th, 2009, that's when it started getting crazy. Now, is that because what happened here? 923. Okay. Now, is that because the infection just took off, or is that because we just had a lot more testing going on and the testing was lagging? This is a problem. 19. On the 19th, 3,954, almost doubling in 24 hours. Wow. Enter. On the 20th of March, again, almost doubling, 5,683 reported cases by 5 p.m. on that Friday, the 20th of March, 2020, I think it was. And Saturday, the 21st, 8,000, not quite doubling that time, 115. Enter. All right, so let's do Zoom 9. Oh, that's why it looked terrible last time. Yeah. All right, I didn't do Zoom 9 last time, so it looked terrible. All right, and then StatCalc 4 or 8, really is the same thing. Let's put this, in Y1. So I don't have to type it, but I can still graph it. And now the R is only 68.980%. That's terrible. The R squared is even worse. It's less than 50%. Oh my God, 47 point something percent. That's terrible. Now, just for fun, I'm going to put in Y2. Let's put in Y2 StatCalc 8 and show you that it's really basically the same thing. Function 2. All right, so A is the y-intercept and B is the slope because it's bx, right? Let's see what we see here. So notice how it's written. It's written backwards. It's written in y1, it's mx plus b. It's 243x minus 1,632 something. Now, in y2, it's written backwards, but the same thing. It's 243 times x, look, times 243 something times x, right? So that's the slope, mx plus b. So what does that tell you? That the negative 1,632.804-ish or 805-ish is the y-intercept, and it's the same numbers we have up here, right? Let's see. Do we get basically negative 1,632.805-ish? We do. And then for the slope down here, do we get 243.588-ish? We do. Okay. So yeah, so it's the same thing. So you're going to see both graphs, one on top of the other. In fact, you're only going to see one graph since they're going to overlap. You're only going to see the red graph on top of the blue graph, but let's see it. Yeah, see, did you see the blue graph and then got covered by the red graph? So 4 and 8, StatCalc 4 and StatCalc 8 are both the same basic linear model. All right, but that was not great because we only have a correlation coefficient of 68.980%. All right, so that wasn't the homework last week. We got to do one more week and see what we get. All right, StatCalc 4. L1, L2, that's where I put the X's and the Y's. Okay, let's make this a Y1 again. I'll delete Y2 before we graph. and calculate. All right, now we're at 68.9799798%. Wait a minute, I didn't add it. Did I add any more data? So sorry, I have to add more data. What am I doing? All right, so let's go to day 22 now. There you go. Okay, so 22, enter. 23, enter. 24, enter. 25, enter. 26, enter. 27, enter. 29, enter. 30, enter. Oh, wait, again, I did it. It's only up to 28. Okay, so let's delete and delete. Okay, let's add in the last week in March, the last full week of March. Of course, it doesn't count the 29th, the 30th, and the 31st, which were a Sunday, Monday, and Tuesday, because April Fool's Day, April 1st was a Wednesday, right? Okay, let's put in the data. Okay, on the 22nd, we had how many reported cases? 10,764. Wow. All right, let's do that. So 10,764. Enter. All right. Then on the 23rd day, 13,109. No, 13,119. Okay, good. And then on the 24th of March, what do we have? 15,597. Okay. On the 25th was 20,011. Holy moly. And 23,112 on the 26th. And on the 27th, I have 26,697. Wait a minute, I wanted the 28th. And on the 20th of March, we had 30,765 reported cases. All right, let's do a zoom. All right, let's go here and delete Y2. Delete, clear. Where's clear? There it is. Clear Y2. Let's do a zoom 9. It's still there. What's going on? Delete. Let's clear Y1 also. We didn't do Y1 yet. Okay, zoom 9. All right, so there's all the data for 28 days in March. March 1st to March 28th, right? Okay, now let's do the linear model. Stat calc 4. Enter. Vars, yvars function 1. Enter. And we get 81.648%. Is that what we had on Sage? Let me check on the website. Oh, in Google Classroom, I have it running here. 81.648%. Yeah. All right, so that was the homework last week. Take a picture of this graph. And I guess you can just take a picture of this screen right here to give me the R, or R squared if it gives you just R squared. Sometimes it just gives you R squared. Sometimes it gives you both. I mean, R squared is calculated differently, but it works out to R squared, right? And R is 0.8 something. R squared is going to be 0.6 something. When you square a number between 0 and 1, a decimal between 0 and 1, it gets smaller. Like 1/2 squared is 1/4. 0.5 squared is 0.25, right? Okay, so 0.8 squared is 0.64. This is 0.816. Squared becomes 0.667-ish, right? So whatever. All right, so that was last week's homework. Okay, so you're going to do the same thing this week, but you're going to do stat calc 5, quadratic regression. Show me a picture of your quadratic regression just with this same data. You don't have to add all the crazy data that I'm doing today. There's all the data: 1, 1, 2, 2, 4, 7, 12, 14, 25, 32, 53, 88, 137, 185, that's 2 weeks, 269, 464, 923, 2009, 3954, 56, 83, 81, 15, that's 3 weeks, 10,764, 13,119, 15,597, 20,011, 23,112, 26,697, and 30,765. So enter that data into your calculator, your emulator, and give me a quadratic regression and take a picture of the graph and take a picture of the R squared screen, and that's your homework for tonight. Alrighty, so that's that. Now, let's go back to today. Today, what I'm going to do is I'm going to add more data. And here's the data. They already, total cases, they already updated 9:30 this morning. I don't have that data in my model. I'm not going to update my model until I have a full day's worth of data. So AM, notice how they're, like April 5th, there's AM and PM. April 4th is AM and PM. Okay, so that's this model here, I think. Let's see, what's this? Yeah, okay. So look what I did here. I rewrote it a little bit so that you could tell which dates we're on. Okay, so here's the first 28 days again of March, right? All the way up to 20,011. What happened? Wait. Here are all the same pieces of data up to the 22nd. Then on the 23rd, that website I just showed you, this thing, on the 23rd, it started giving data two times a day. See, on the 23rd, there's an AM and a PM, but on the 22nd, there's only a PM, and the 21st is only a PM, and the 20th is only a PM. That's the data we were using. All right, so now what I'm going to do is I'm going to add two pieces of data from then on. So I had on the 23rd PM, we had the 13,119, but now I'm going to add on the 12,339 in the AM. On the 24th, we had the 15,597, but we're going to add on the AM, line 27. We didn't have line 27. On the 28th, we had 2,000, no, on the 25th PM, we had 20,011. On the 26th PM, we had 23,112. On the 27th PM, we had 26,697. Let me just double check my other computer. Is that right? On the 27th, we had 26,000. Yeah, that's right. And then look at line 36, we had 30,765 for the PM of the March 28th. We did not have the data that I have here now in line 35, 29,158. Okay. So there you go. So I'm adding all those AMs and PMs. Okay. So on the 29th, we didn't have the 29th on that last model. Okay. So now we have two pieces of data for the 29th, two new pieces of data on the 30th, two new pieces of data on the 31st, two new pieces of data on April 1st, April 2nd, April 3rd, April 4th, and that's it up till yesterday, right? All right, so let's run this up to the 28th like we had before. But now I have a couple extra pieces of data for the morning of the 23rd, the 24th, the 25th, and the 26th, and the 27th, right? So I'm going to cut out of here. Let me cut out of here the data from the 28th on, this much. All right. Now, where am I going to save this? That's a problem. All right, let's get rid of that for the moment. All right, so instead of a comma there, I need a square bracket. All right, so this is still up to the 28th, but now we're adding a couple of AMs that on the 23rd, 24th, 25th, 26th, 27th, and the 28th. Wait a minute, it took too many. Starting here. I want two 28ths, right? Yeah, okay. So instead of 28 data points, I have 34 because I've added a few more. Okay, good. Now I need to save this someplace. Let's see. Let me email this to myself. I don't lose it. I don't have anywhere else to write stuff on my Chromebook. All right, so let's compose. I'm going to just put this in a note to myself. Go on today. What's going on? Alrighty. So I'm not even going to send it. I'm just going to paste it here. Okay, there's all the data I cut out, right? All right, so let's leave that there. And let's run this model with a couple more pieces of data up to the 28th. All right, so sample size now is 34. All right. And so here's my linear model. Here's my quadratic. Notice it's a little more bumpy with the AM. See it? The blue stuff. Here is the cubic regression. Here's the quartic. Alrighty. Which isn't great because it looks like it's leveling off at the top there, but then it's going to go all the way down to 0 again. No, I don't think it's doing that. Right? Go into negatives and whatnot. Here is another linear model. Here is the logarithmic, which is terrible. Here is the exponential, which people think it's exponential, but it starts exponential, then it levels off. Here's power. That's no good. And here's the logistic. Look, that's not terrible. So it looks like it's leveling off at about 40 data points. Alrighty. We have 34 data points. So that's 6 more data points, 2 points a day. That's 3 more days. Oh, wow. So it levels off in 3 more days after that? Really? Well, maybe more than 40, more like 50. Okay, so from 34 from 50 is 16, 8 more days. Okay, so according to this model, it levels off in 8 more days after the 34th data point, which is the 50th data point, to about 32,800 to 32,900 something, right? Okay, there you go. All right, now let's put in all the rest of the data. Alrighty, so I'm going to put in more data. Let's go back. So that's adding more data up to the 28th. Now let's add the data after the 28th. So let's go back here. Now I'm going to copy. So what is this now? 1, 2, 3, 4, 5, 6, 7 more days. Right, perfect. All right, so let's copy that. Come on. Okay, mouse. There we go. Control C that. All right, let's go back here and add one more week of data. It's 14 data points, though, so we're going to have, well, let's see how much we have. I thought we were going to have 50 altogether. Okay, let's paste that there. Okay, so this has to get indented. This has to become a comma. Alrighty, and then this, okay, I think that's good. So it's 48 data points. What happened to April 5th? Oh, I don't have April 5th on here. Okay, let's add on April 5th. Here we go. So let's go here, and April 5th AM is 63,767 cases. All right, in the AM. Alrighty, so let's put that in there. So I'm going to move this down. I'm going to say square brackets. 49th piece of data is Sunday morning, yesterday morning, April 5th. And we get that many more. Okay, so this becomes a comma. And this is the wrong date. But now, this, you know what, I'm going to make this a comma and make this the AM of the 5th, which is yesterday. Okay. All right. And then I have to do one more. Okay, here we go. All right, so this is going to be the 5th and the PM. All right, let's find that data. That's, give me the total cases. The 5th in the PM, yesterday, 4:45 PM. You could download all these PDFs, right? And let's add that into the equation. So that's adding actually 8 days of data after the 34 that we had. So 1, 2, yeah, so I'm up to 8 days later, 16 more data points, more afternoon and evening, AM and PM, right? So I'm going to put 50, comma, that. There you go. Okay, let's evaluate this, see what happens. Okay, what do I do? Oh, this is a square bracket. No, what do I do now? I did something weird. Line 38. I'm not seeing it. Line 38. Why line 38 when it was okay up to 30? What? 38. Did I have another square bracket in there? No. All right, you know what? Let's just go back to this model, which has all 48. It just doesn't have the 50. Okay, it doesn't have. Let me add the 2 more days. Because this works, right? This is working. Okay. So let me just add 2 more days. Square bracket, comma. Square bracket, bracket. Let's add on the 5th. Whoops. In the AM and the 5th in the PM. This will be the 49th data point and the 50th data point. All right, let's fill this one in again. All right. Let's copy that over. Okay, good. And copy this over. Right here. And make this a comma. There you go. All right, sample size is 50 now because we added 8 more days or 16 more data points, AM and PM, right? And there's your linear regression. There's your quadratic. This is not what you're doing. You're only doing 28 days on the calculator tonight, but you're doing quadratic on the calculator. Here's your cubic. None of these are great. Here's your quartic. Here's your linear again. Here's your logarithmic. Here's your exponential. So it's clearly not exponential. Look at it. It's starting to level off a little bit. Right, the blue stuff is leveling off. The red stuff is not. The red stuff is the exponential model. That's not great. All right, here's the power regression. That's not great. Here's the best match, I think, right here. Okay, and I think I ran this for 4 times the sample size just to see how it's really leveling off. All right. In this case, the linear model is 95.931 correlation coefficient. All right, here's the data that was inputted in this middle column, and the third column is my logarithmic model. All right, so if we're up to 50 data points, and this is my logistic model, right? That's the first, the April 1, 2, 3, 4, 5, and March 1st to 31st. It's the first 36 days, right? All right, so let's see. How long does it take to level off? Let's see. Before it changes too much. 73,000, 200, 207, 208. All right, it looks like it levels off at 73,208. Now, it's the first time we see that. We see that at day 125. So subtract 50 from that, because we have 50 data points. That's 75 data points. Round figure 76. Chop that in half because there are 2 data points per day. And so that's going to be 38 days. So this model predicts a leveling off of the New York City population's infected population to 73,208 people in 38 days from now. So a little bit over, what was that, 5 weeks? 5 weeks would be 35 days. All right, so if this is, let's say we're stopping here. If this is 38 days from now, this is 37, the end of the 37th day, this is the end of the 36th day, and this is the end of the 35th day. So let's say in 5 weeks, 5 times 7 is 35 days, right? We're up to 73,200 something people. for more or less a peak or max population of infected people in New York City. So it's going to take 5 weeks, but notice how the max keeps on getting bigger and bigger and bigger as they start reporting more and more infecteds. Yeah, so we're still predicting leveling off in about 5-6 weeks, just like last time. I think it was 4 or 5 weeks last time. But the max is getting higher. Wow. All right, that's it for today. I think we're good. So let's see, just for fun, take a look at this logistic code on the bottom. The link is in Google Classroom. You can look at it. But notice the logistic code here is going 4 times the sample size. So sample size is 50 pieces of data, so it's going up to 200 pieces of data altogether to show the leveling off. This one's only going to sample size because it's printing out the sample. We don't have more than 50 pieces of data. And the actual graph is going to 4 times the sample size also. All right, so when you take a look at the logistic results, right, this is going to 4 times the sample size. The sample size is 50 pieces of data. We're going up to 200 pieces of data, let's say, that we don't have. We're extrapolating it from beyond the domain of the data, right? And then this is the same thing, just numerically. And then this is the same thing up to 50 points of data, right? Now this takes the logistic model and extrapolates it all the way to 200 pieces of data. In other words, 200 from minus 50 roughly is 150, so 75 days later. But it maxes out way before 75 days from now, as you know. All right, so that's it. All right, so I hope you have fun with that homework tonight. Use a graphing calculator.